Hello students, today we will continue our discussion on mathematical tools in physics, and today will be the second part of the chapter in which we will focus on trigonometry. Now in class 10 already you have been introduced with the concepts of trigonometry, in which you have studied about different trigonometric ratios: sine theta, cos theta, tan theta, cot theta, cosec theta, sec theta. These are all ratios regarding the different sides of a right angle triangle. Now, since these ratios are basically about different angles, so today we will begin our discussion with the basic concept of an angle. So what is an angle? For this, let me draw a straight line and name it as OX. Now, suppose OX is a straight line revolving about its one end O. After some time, let it reach a position OX dash. Suppose this is the position X dash. So the point X has moved up to X dash. The amount of revolution of this line is called the angle traced by the line. I repeat, the amount of revolution of the line is called the angle traced by this line. Let us represent this angle with theta. Then angle X O X dash is equal to theta. Now theta is taken as positive when the rotation is anti-clockwise, as I have shown in the diagram. Theta is taken as positive when the rotation is anti-clockwise, and theta is negative when the rotation is clockwise. So theta is positive for anti-clockwise rotation and theta is negative for clockwise rotation. Now there are different systems for measurement of an angle. The first one being the sexagesimal system, in which angle is measured in degrees, minutes and seconds. So one right angle, as we all know, is 90 degree. 1 degree is equal to 60 minutes. 1 minute is equal to 60 seconds. This we all know. The next is the circular system, in which angle is measured in radians. Now, what is 1 radian? For this, let me draw a circle. Suppose this is a circle with its center at this point. Now, let us draw two radius, OP and OQ. Let me draw the radius once more. So OP and OQ are the two radius. Then if the radius is denoted by R, then the condition is that the length of the arc PQ should also be equal to R. Okay. So the angle in this case, POQ, angle POQ is equal to 1 radian. So how to define 1 radian? 1 radian is the angle subtended at the center of a circle by an arc equal in length to the radius of the circle. This means we are considering the arc PQ having a length equal to the radius of the circle. The radius of the circle is also equal to r, so length of the arc is also equal to r. See, OQ is equal to radius of the circle, and this is also equal to OP. So the arc PQ, the length of this arc, is also equal to the radius. So the angle subtended by this arc of length equal to radius of the circle is given by 1 radian, isn't it? So now let us obtain some expressions using this concept of 1 radian. A radian is a constant angle. 2 pi radians is equal to 360 degree, isn't it? Say you begin moving in the anti-clockwise direction after one complete rotation. After one complete rotation, the angle subtended should be equal to how much? 360 degree, and that is given by 2 pi. 2 pi radians is equal to 360 degree. Therefore, 1 radian should be equal to how much? It should be equal to 180 degree divided by pi, and that is equal to 57.27 degree. So 1 radian is equal to 57.27 degree. Now if L is the length of the arc, R is the radius of the circle, then theta, that is the angle subtended by the arc at the center. Angle subtended by the arc at the center, theta, is given by L by R. So this is one important expression that you should remember. Theta is the angle subtended by an arc of length L at the center of a circle of radius R. So angle is given by theta equal to L by R. Now we will define the 4 quadrants. As you can see, I have drawn 2 mutually perpendicular lines. Let these lines be X, O, X dash and Y, O, Y dash. These lines divide this plane, the plane of this board, into 4 parts, isn't it? Each part is called a quadrant. So XOY is the first quadrant, YOX dash is the second quadrant, X dash OY dash is the third quadrant, and Y dash OX is the fourth quadrant. So in this manner we can define the 4 quadrants. Now very quickly I will show you how we can find out the angles in these 4 quadrants. I will show you how to find out the angle in the first quadrant, and similarly we can generalize the same for the different quadrants. Now let a line OP coinciding initially with OX revolve about O in the anti-clockwise direction and trace a angle theta. So from P we will drop a perpendicular M on OX. Thus we obtain a right angle triangle OPM. So and the angle theta in the first quadrant is given in this manner. So in this way we can obtain the angles in different quadrants, like the extent to which the line OP, which was initially coinciding with the OX axis, that is OX line, keeps on revolving in the anti-clockwise direction. So if it is revolving in this manner such that the angle POX is theta. So this is how we will label the angle in the first quadrant. So let us see how we will show it in the different quadrants. So we have already discussed the first quadrant. In the second quadrant, you can see the same line OP is in the second quadrant, and how the angle theta has been shown in this one. Similarly, in the third quadrant, the angle theta, and in the fourth quadrant. So in this manner, we can find out the angles in all the different quadrants. Now very quickly, we have to remember the different trigonometric ratios. So the trigonometric ratios. For this, we have to consider a right angle triangle ABC. As you can see, I have already drawn on the board. I mark the angle theta. BC is the perpendicular denoted by P, AB is the base and denoted by B, and AC is the hypotenuse that is denoted by H. Then we can obtain how many? 6 different ratios. So first of all, sine theta, that is equal to perpendicular by hypotenuse, cos theta, base by hypotenuse, tan theta, perpendicular by base. Now tan theta is actually equal to sine theta divided by cos theta. Similarly, you can write down cosec theta. Cosec theta is hypotenuse by perpendicular. This is equal to inverse of sine theta. Sec theta, that is equal to hypotenuse by base. This is 1 upon cos theta. And lastly, cot theta. This is equal to base by perpendicular. This is 1 by tan theta, or you can write down cos theta by sine theta. So in this manner, we can define 6 trigonometric ratios. Now the question arises, how to decide in which quadrant which ratio should be positive. So let us again draw the 4 quadrants, and I will write down these 4 alphabets. Now you might be wondering, what does ASTC stand for? A stands for all, S stands for the ratios related to sine, so sine theta and cosec theta. T stands for the ratios related to tan and cot, and C stands for the ratios related to cos, that is cos and sec. So all sine, tan, cos. So in the first quadrant, all the trigonometric ratios are positive. All the 6 trigonometric ratios are positive. In the second quadrant, only sine theta and cosec theta are positive. Only sine theta and cosec theta are positive. In the third quadrant, only tan theta and cot theta are positive. While in the fourth quadrant, only cos theta and sec theta are positive. I will repeat once again. In the first quadrant, all the 6 trigonometric ratios are positive. In the second quadrant, only sine theta and cosec theta are positive. In the third quadrant, only tan theta and cot theta are positive. While in the fourth quadrant, only cos theta and sec theta are positive. Further, you should remember the sine theta is never greater than 1 and cos theta is also never greater than 1. The values of sine theta and cos theta lie between -1 and +1. However, tan theta and cot theta can have any real value. Now I will be writing down some common trigonometrical relations that you might all be well aware of. So just now I wrote down tan theta is equal to sine theta by cos theta. Then cosec theta is 1 upon sine theta. Sec theta is equal to 1 upon cos theta. Cot theta is equal to 1 upon tan theta. Sin square theta plus cos square theta is equal to 1. Now you may also write down sin square theta equal to 1 minus cos square theta, or cos square theta equal to 1 minus sin square theta. Sec square theta minus tan square theta is equal to 1. And lastly, cosec square theta minus cot square theta is equal to 1. So you need to remember these 7 relations. Tan theta equal to sin theta by cos theta, cosec theta equal to 1 by sin theta, sec theta equal to 1 by cos theta, cot theta equal to 1 upon tan theta, sin square theta plus cos square theta equal to 1, sec square theta minus tan square theta equal to 1, and lastly cosec square theta minus cot square theta equal to 1. All these trigonometrical relations, or what we call identities, have already been taught in class 10. Next we will discuss trigonometric ratios of allied angles. When the sum of two angles is equal to 90 degree, they are called complementary angles. When the sum of two angles is equal to 180 degree, they are called supplementary angles. This you all know. Now you might be wondering, what are allied angles? Let me tell you. The angles whose sum or difference with angle theta is 0 or a multiple of 90 degree. The angles whose sum or difference with angle theta is 0 or a multiple of 90 degree are called angle allied to theta. I will repeat once again. The angles whose sum or difference with angle theta is 0 or a multiple of 90 degree are called angle allied to theta. Now we will be discussing it one by one. So first of all, sine of minus theta is equal to minus sine theta. Cosec of minus theta is equal to minus cosec theta. Cos of minus theta is minus cos theta. Sec of minus theta is sec theta. Tan of minus theta is minus tan theta. And cot of minus theta is minus cot theta. For example, if I write down sine of minus 30 degree, so that should be equal to minus sine 30 degree. Similarly, if I write down cos of minus 30 degree, then that should be equal to plus cos 30 degree. Sine of 90 degree minus theta, that is equal to cos theta. Cosec 90 minus theta is sec theta. Cos 90 minus theta is sin theta. Sec 90 minus theta is cosec theta. Tan 90 minus theta is cot theta, and cot 90 minus theta is tan theta. Now all these angles, 90 degree minus theta, this lies in first quadrant. So all the trigonometric ratios are positive. You can see that all of them are positive as the angle lies in the first quadrant. Like for example, if you are given sine 30 degree, so sine 30 degree will be equal to cos 90 minus 30, that is equal to cos of 60 degree. So sine 30 degree is equal to cos of 60 degree. Similarly, cos of 60 degree, that is equal to sine 90 degree minus 60 degree. So that is equal to sine of 30 degree. Sine 90 degree plus theta is equal to cos theta. Cosec 90 degree plus theta is sec theta. Cos 90 degree plus theta is minus sin theta. Sec 90 degree plus theta is minus cosec theta. Tan 90 degree plus theta is minus cot theta, and cot 90 degree plus theta is minus tan theta. Now the angle 90 degree plus theta lies in the second quadrant. 90 degree plus theta lies in the second quadrant. So cos theta and tan theta, they are negative. So accordingly sec theta and cot theta should also be negative. Only sine and cosec are positive. So sine theta and cosec theta, they are positive. Rest every trigonometric ratio is negative. For example, sine of 120 degree, that will be equal to sine of 90 degree plus 30 degree. So that will be equal to cos of 30 degree. Similarly, cos 150 degree, that should be equal to cos of 90 degree plus 60 degree. So that will be equal to minus of sine 60 degree. In this manner, we can find out the trigonometric ratios. Sin 180 degree minus theta is sin theta. Cosec 180 degree minus theta is cosec theta. Cos 180 degree minus theta is minus cos theta. Sec 180 degree minus theta is minus sec theta. Tan 180 degree minus theta is minus tan theta, and cot 180 degree minus theta is minus cot theta. Again, the angle 180 degree minus theta lies in the second quadrant. So that's why only sin theta is positive. Sin theta and cosec theta both are positive. Rest every trigonometric ratio is negative. So like for instance, if you are writing down sine of 150 degree, so that may be written as sine of 180 degree minus 30 degree. So that should be equal to sine of 30 degree. Similarly, cos of 135 degree will be equal to cos of 180 degree minus 45 degree, and that should be equal to minus cos of 45 degree. Okay. Sin of 180 plus theta is minus sin theta. Cos of 180 plus theta is minus cos theta, and tan of 180 plus theta is tan theta. Now 180 plus theta lies in third quadrant. So only tan theta is positive. Like for example, tan of 210 degree, that will be equal to tan 180 degree plus 30 degree. So that should be equal to tan of 30 degree. But suppose you are calculating sine of 240 degree. So that should be equal to sine 180 degree plus 60 degree. So that should be equal to minus sine of 60 degree. Sin 270 degree plus theta is minus cos theta. Cos 270 degree plus theta is sin theta, and tan 270 degree plus theta is minus cot theta. Now angle 270 degree plus theta lies in the fourth quadrant. So only cos theta is positive. Like in the previous case, these lied in the third quadrant. So only tan theta was positive. So now 270 plus theta, this angle lies in the fourth quadrant. So only cos theta is positive. Like for example, cos of 290 degree, that should be equal to cos of 270 degree plus 20 degree. So that should be equal to sine of 20 degree. Sin 360 minus theta is minus sin theta, cos 360 minus theta is cos theta, tan 360 minus theta is tan theta. Angle 360 degree minus theta again lies in the fourth quadrant. So only cos theta is positive. Lastly, sin of 360 plus theta is sin theta, cos 360 degree plus theta is cos theta, tan 360 degree plus theta is tan theta. 360 degree plus theta, this lies in the first quadrant, so all the trigonometric ratios are positive. Like for example, sin of 400 degree, so you can write down as sin of 360 degree plus 40 degree, so that should be equal to sin of 40 degree. Okay, very quickly then we will remember the values of trigonometric ratios of standard angles. So for 0 degree, sin theta is 0, cos theta is 1, tan theta is 0. For 30 degree, sin theta is 1 by 2, cos theta is root 3 by 2, tan theta is 1 upon root 3. For 45 degree, sin theta is 1 upon root 2, cos theta is 1 by root 2, and tan theta is 1. For 60 degree, sin theta is root 3 by 2, cos theta is half, tan theta is root 3. For 90 degree, sin theta is 1, cos theta is 0, tan theta is undefined. For 120 degree, sin theta is root 3 by 2, cos theta is minus half, and tan theta is minus of root 3. For theta 135 degree, sin theta is 1 by root 2, cos theta is minus 1 by root 2, tan theta is minus 1. For 150 degree, sin theta is 1 by 2, cos theta is root 3 by 2, tan theta is minus 1 by root 3. For 180 degree, theta equal to 180 degree, sin theta 0, cos theta is minus 1, and tan theta is 0. For theta equal to 270 degree, sin theta is minus 1, cos theta is 0, tan theta is undefined. And lastly, for theta 360 degree, sin theta is 0, cos theta is 1, tan theta is 0. So you need to remember these values. For the standard angles, you need to remember the values for sine, cos and tan. If you can remember for sine theta, cos theta, tan theta, then very easily you can calculate the values of cosec theta, sec theta and cot theta, isn't it? So you can remember the values from 0 to 360 degrees for the different trigonometric ratios. Okay. Now we will discuss the addition formula. Sin of a plus b is equal to sin a cos b plus cos a sin b. Cos of a plus b is equal to cos a cos b minus sin a sin b. Tan of a plus b is equal to tan a plus tan b divided by 1 minus tan a tan b. Now these formula you need to remember. These are called the addition formula because we are simply adding the two angles. Now if we put b equal to a, like for instance in place of sin a plus b, if I write down a plus a, so it will become sine of 2a. So this will give you the result sine 2a equal to 2 sin a cos a. Similarly cos 2a you will be getting cos square a minus sin square a. Now one more identity we are knowing, that 1 is equal to sin square a plus cos square a, isn't it? Sin square a plus cos square a is equal to 1. So on substituting that particular result, you get two more expressions for cos 2a. cos 2a is also equal to 1 minus twice sin square a and 2 cos square a minus 1. Similarly, for tan 2a, you get twice of tan a divided by 1 minus tan square a. Next, the difference formula. Sin of a minus b is sin a cos b minus cos a sin b. Cos of a minus b is equal to cos a cos b plus sin a sin b. And tan of a minus b is equal to tan a minus tan b by 1 plus tan a tan b. Now, next we will discuss the transformation formula. Like for example, if I add these two, sin of a plus b plus sin of a minus b, then what will you get? You will get 2 sin a cos of b. Similarly, cos of a plus b plus cos of a minus b will give you twice of cos a and cos b. Now on subtraction, like if I subtract sin of a plus b minus sin of a minus b, that will give you twice of cos a sin b. Similarly, cos of a minus b minus cos of a plus b will give you twice of sin a and sin b. Now, if we put a plus b equal to c and a minus b equal to d, we put a plus b equal to c and a minus b equal to d, then what will happen? You will get a equal to c plus d by 2 and b will be equal to c minus d by 2, isn't it? So now you can get some more expressions. You will get sin c plus sin d equal to 2 times sin of c plus d by 2 and cos of c minus d by 2. Cos c plus cos of d will be equal to 2 times cos of c plus d by 2 sin of c minus d by 2. Sin of c minus sin of d will be equal to 2 times cos of c plus d by 2 sin of c minus d by 2. Cos d minus cos c will be equal to 2 times sin of c plus d by 2 sin of c minus d by 2. Or you can write down cos of c minus cos of d equal to minus 2 times sin of c plus d by 2 sin of c minus d by 2. So whole lot of expressions are there that we need to remember from trigonometry. It's quite a lengthy topic, and just simply remembering this expression is going to help you a lot in deriving a lot of formula in physics. Not every single expression will be used, but some out of these will certainly be used while we are doing the different derivations. So we need to go through all these expressions carefully. Lastly, we will see sine and cosine formula for a triangle. Okay. So for this, if suppose I consider a triangle ABC and I mark the angles, angle A, angle B and angle C, and if the sides are given as this means the side opposite to angle A is marked A, side opposite to angle B is marked B, and side opposite to angle C is marked C. Then we can get A by sin A equal to B by sin B equal to C by sin C. You can write down A square equal to B square plus C square minus 2BC cos of A. You will get B square equal to C square plus A square minus 2CA cos of B. C square is equal to A square plus B square minus 2AB cos of C. And lastly, area of triangle ABC will be equal to under root S minus A into S minus B into S minus C, where S is equal to A plus B plus C by 3. So this can be written for the different expressions for a triangle. This is nothing but Hero's formula. Actually, this you have already studied in your junior classes. S is A plus B plus C by 2. So these are a couple of topics that we need to understand in trigonometry.